difference between the two types of cells, and why I think the dry cell is the way to go. First, let's take a look at what we call the wet cell. Now, most of the designs you're probably familiar with if you've been following HHO for a while are what we consider a wet cell. The water for gas, the mason jars that has a couple of stainless steel wires wrapped around the inside of that, that's a wet cell. The water filter housings where you take you stack your stainless steel plates up and dip them inside of a bath of water inside of a water filter housing, that's a wet cell. Stanley Meyer's design, that would be considered a wet cell. Basically, a wet cell is anything where you've got any type of a cell where you've got the plates, the wires, the tubes, whatever it is, submerged in some sort of a container that has your electrolyte in it. And then you run your wires or your metal straps or bands or whatever down into the bath of water to connect to your plates or your tubes. Here's an old cell that I made, one of the first ones that I played around with. It's basically just 7 plates, and that was submerged into this container and then sealed off with your electrical connections on the top, your positive and your negative. The problem with that design is the current wants to go from the positive over to the negative plate and take the least path of resistance. So it's, instead of forcing its way through those plates, which it will, a lot of that current's going to get wasted. It's going to bleed off the edges of these plates, both the bottoms and the sides. Now this one I covered up with a piece of inner tube, which helped some of the leakage with the sides, but it was still just bleeding out the tops and the bottoms. A very inefficient design. Another problem with the wet cells is for safety considerations. If they're not built properly, it could be a safety hazard. The problem is in order to get the positive and the negative contacts down into that bath, you've somehow got to get a wire or a strap or something down through there. Let's say you run a wire from the positive up here down through here and connect it to the plates inside the bath. You have one little spark down in there. It's going to create a short, and all the gas that's accumulated here is going to explode. And if you have a mason jar, or depending on whatever your container is, it could explode and send shards of glass or whatever your container is made of flying. So another reason why the wet cell design has the possibilities of being a less safe design, but it's definitely less efficient regardless. Okay, so now that I've explained what a wet cell is, let me show you a dry cell. What I have here is a 6-inch EBM dry cell. It has 19 plates in it. I think I misspoke in a previous video and said it was 21 plates. But what a dry cell consists of is 2 of these big plastic end plates, and if you look in the middle, there's a bunch of stainless steel plates sandwiched in the middle with gaskets in between, and then the electrical connectors on the top. And what's happening here is the water from the reservoir above is coming through this tube here. It's going down into the stack of plates. There's holes in the plates, which I'll show you in just one second. The water circulates through all of here. When the 12 volts is applied up here, the electrolysis takes place, and the HHO gas and the electrolyte is kicked out of this top fitting right here and circulated back into the reservoir. The water just keeps recirculating, and the HHO gas floats up and out. Now what's nice about the dry cell as opposed to the wet cell is these connectors on the top. If you notice, none of the electrical connections touch water at any point. When you see the inside of how it's put together, you'll see there's no way at any point for anything electrical to come into contact with the water that could possibly short out. That's one of the things that makes it so much safer than a wet cell. I'll show you the inside now. I got some plates and gaskets. I'll show you. It'll help you wrap your head around exactly what's going on inside the cell. Okay, the inside of a dry cell is actually very simple. You've got 3 components that make it up. You've got your end plates, you've got your gaskets, and you have your stainless steel plates. These gaskets generally are made out of neoprene. In this case, that's what these are, neoprene gaskets. They're 1/16 of an inch thick. Some people like to use 1/8 of an inch spacing. To each his own, I guess. Anyway, back to the dry cell. You've got your end plate. It normally has bolts going through these outside holes. I've left them out just so it's easier to stack. Okay, so all you do is you take one of your gaskets, you lay it down on there. It's going to create a little cavity in the middle, 1/16 of an inch deep. That'll allow the water to flow in that cavity. Okay, then you take one of your stainless steel plates and just lay that on top of there.
Bê 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 rồi.
Lay that on top. And you get the idea. You're going to continue this just until you get a big giant stack of all these plates and gaskets. And if you look at that, the gasket seals on here. It covers all the inside where the bolts will be going through. So none of that is going to be exposed to any kind of water. Just
Cách
this
làm
inside
máy
area where again you
phân
have
tử
1/16
oxy
gravity
tách ra
is going
khỏi
to allow
nước
water to
từ
flow
điện
through these
phân
plates, through these holes
bắt
right
từ
here. You have one
nguồn
hole at
điện
the bottom,
bình ắc quy
3 holes
12V.
Now, this is the only place on this plate where current can leak. That's one of the problems that we have with wet
Tạo
seals.
ra khí
Even in the case of
oxy.
the one that I showed earlier, where the plates were covered up with the inner tube, the bottoms of the plates were still exposed, and current can jump out of the bottoms of the plates. It's a very inefficient design. In this case, the only place that the current can jump is through these 4 holes in the plates. The ultimate dry cell is one that has no holes in it. If you can figure out a way
Các nhà cơ khí Việt Nam
other than going through the holes in the plates.
có điều kiện máy móc, nguyên liệu có thể xem video này bắt chước họ sản xuất máy tách Hikaru từ năng lượng bình ắc quy 12V, có thể sử dụng cho máy nổ, phát điện, thậm chí cả ô tô. Năng lượng sạch chạy bằng nước. Hikaru.
Swear by his design with the tubes and a bath of water, and that's fine. It could be that there is a way to get more efficiency out of that design. I think it has to be. It's a lot more involved. It has to do with high voltage and a lot more electronics.
From Evolution HHO, and we are going to do a cell test the way it should be done in a vehicle. Very rarely are we using cells on a bench, maybe here or there for a torch, but generally everybody's interested in is how does a cell perform when it's in a vehicle? And it's a big difference when it's in a vehicle and on a bench. You can really dial things in to get cells to do a whole lot more. But that's just not real life. I'm going to go through this installation I did in the Lincoln Navigator. I got it kind of set up, ready to go through here to do a test. So let me rip through it quick here. We got your typical measuring device with the float up liter bottle. I have a 5-quart tank. I don't know if you can see the hoses going straight down. Here's the wiring. Yeah, okay, tell me about it. Shoemakers, kids wear bare feet, but it's not that bad. We got circuit breaker here. I got amp meter. We're running with a current controller at 20 amps. We're running just a shade less than 11 volts. Let's call it 11 volts. Here's my current controller, it's Dan's. Fan's going, you can see we're hooked up correctly. What we're going to do now is we're going to go under and we're going to look at the cell. I'll show you the installation. Obviously you're getting a good picture of stuff that you don't need to see, like my grill. But here's the installation. The cell fits nice and flat against the frame. I have my ground isolating bracket. This is the all-steel design, and what I mean by all-steel design is you don't have end caps, and you don't have plastic fittings over here, so there's just no chance of leaks, and it just seems to run so much cooler than anything I've ever tested in plastic. We're going to put the heat gun to it, classic heat gun. Thing is running at 90 degrees, obviously, well, we're right underneath the radiator, so running pretty cool at this point. I'm going to come up and we're going to try to do the impossible, which is start an iPhone test. Start an iPhone stopwatch at the same time while holding a camera and putting a hose on. So let's go with it right now. There we go. Come on. That was pretty close. You can actually go on the bottom of the screen. Obviously, YouTube has the bar bar in the bottom that shows time, so if I don't get it exactly right, well,